Bismillah Rahman Rahim. Welcome to my channel Learn Math with Sayyid Ali. One of my 10th grader has sent me this question. You and your partner are observing an aircraft from two observing decks. So these are the two observing decks, and they are 5 kilometers apart. From your point of view, aircraft is at an angle of elevation of 70 degree. And from your partner point of view, the angle of elevation is 55 degree. Determine the altitude of the aircraft. So, first thing first, what is the altitude? Altitude is the vertical distance from the apex to the base, right? So this is the vertical distance. So that means this side is required. So second thing is important, to name the triangle. Let's say that you are at A, partner is at B, and C is your aircraft. And what is required is CO, that is altitude, vertical distance, right? So this is altitude of this triangle. What is the altitude of the aircraft, right? Now in this triangle, we can see that by this altitude, we have two right angle triangles. One is this and other is this, right? We can work on any triangle, but we can see that before working on the right angle triangle, we have to solve ABC, a non-right angle triangle, which is this, right? ABC is a non-right angle triangle. It's not a right angle. So this ABC, if we have to work on this first, and then maybe we can use the right angle triangle. That means ABC, this angle is 70, this angle is 55, and this is 5 kilometers, right? So this thing is given 70, right? So what is first and foremost thing you have to find out is this side, right? Right, this side. And if you find out this side, then we can go back to our original right angle triangle, which is COB, where we can find out the altitude. So first thing is to find out CB. And CB, we can see that two angles and one distance, or the one side length is given. When two angles and one side is given, we can easily use the sine law, right? What we can see, that we can find out this angle C as well, right? So what will be the angle C? So angle C will be equals to, using the property of a triangle, 180 minus the sum of two angles, 70 plus 55, right? 70 plus 55. So 180 minus 125, right? So 180 minus 25 is again 55. So angle C is also 55, right? So now we have this angle as well. Now I have to find out what is my side length CB. What is CB? So CB, for CB, I can use sine law. Use sine law, right? We have videos on sine and cosine law practice, but now we are using here sine law. Maybe we are using here the sine law together with the trigonometric properties, which is sine, cosine, and tangent, and which we learn as SOHCAHTOA. Sine is opposite over hypotenuse, cos is adjacent over hypotenuse, tangent is opposite over adjacent. We have already done that exercise. So what is CB? CB is this side, right? So I will be saying C over sine C is equals to, so we know that this is small c, right? C over sine C is equals to A over sine A. A over sine A. And what is A? A is this measurement, right? Which is unknown. Opposite to the angle A, always opposite to, right? Small alphabet, we did that. Okay, so now we can plug in the values and we can get this CB or A. So A will be equals to C times sine A and sine A. What is sine A? Sine A is 70. So I'll substitute the value divided by sine C. And what is sine C is 55. Now I can plug in the values. So C is known, 5 kilometers. Sine 70, 0.9396 divided by sine 55, which is 0.8192. And if we calculate this, you can calculate all the values by the calculator and substitute in the calculator maybe and get the answer. So your A will be 5.7. Right? So this side we now know that it is 5.7. If we know A, that is this side is now known, right? So my A is, this side is 5.7. Now I have this right angle triangle, which is like this. OCB. And this is my required unknown, right? So if ACB is this and A is known 5.7, right? Or we can also find out, we can find out OC. OC with the help of this sine, because I know this sine, right, with this angle. So I can use my sine 55, trigonometric ratio. Sine 55 will be equals to, sine is opposite over hypotenuse. So what is opposite, right? So we will see that what my opposite is. Sine 55, I can put the value of sine 55. So sine 55 is equals to, what is my opposite here? Opposite to this, OC, right? So which is required, right? So OC divided by hypotenuse. Hypotenuse is 5.7. So my OC will be equals to 5.7 times sine 55. So if you guys calculate this OC will be equals to 4.67 kilometer. Answer may vary, because if somebody is using all values of the sine 55 or rounding off to the 2 decimal places or 1 decimal places, answer will be slightly vary. So the altitude of the aircraft, is how much? 4.67 kilometer. This is my answer. So here in this example, we use the sine law, right? And then with the help of the sine law, we know the side. And once we know the side, we can use the trigonometric ratio. And all trigonometric ratio, for your review, a quick review, for all trigonometric ratio is SOHCAHTOA, right? What is sine? Sine is so. So it says that sine is equals to opposite over hypotenuse. Ka is this, like cosine, C for cosine, A for adjacent, H for hypotenuse, TOA, TOA. T for tangent, O for opposite, A for adjacent. So all of the trigonometric ratios, sine, cos, tangent, we learned that in a right angle triangle, we can use SOHCAHTOA to get our desired sine, or there are 3 variables, right? So there are 3 variables. If 2 of them are known in each, we can find out the 3rd variable. And here also we know the angle and we know one side, right? So the 3rd variable, which was OC, we calculate this side, right? Because sine 55 is opposite over hypotenuse. Opposite here is OC, and we need OC, right? What is the altitude of the aircraft? Hope you like the video. If you like it, subscribe my channel, press the bell icon button to receive another video. Thank you for watching.